Recording in progress. Hi, students. In this lecture, I am going to discuss problems based on dynamics of shutter motion. Let us see first one. See the question given. A particle of mass m is attached to one end of a massless inaccessible string of length L, whose other end is connected to ceiling. Find the tension in the string when the angle made by the string with the vertical is theta and speed of the particle is v. Assume the motion is confined to vertical plane. So given now, a particle connected to massless inaccessible string, right? So we have to find out tension. Let us see how to solve it. So first we have to focus on free body diagram. First write down given data. So one end of the string attached to ceiling. When string makes an angle theta with vertical, its velocity given as v. So condition given motion confined to vertical plane. So this is nothing but simple pendulum. Let us focus first free body diagram. So how many forces acting on the particle? So first start with gravitational force. It is mg downwards. Tension towards the center. That is T. So only two forces are acting on the particle. Now we have to focus which force we have to resolve. Again here for majority having a confusion, which force we have to resolve. So again basic point is that resolve forces along motion direction and normal to motion direction. That is along velocity, normal to velocity. Since it is now circular motion, velocity will be along a tangent. Therefore, resolve along a tangent and normal to tangent, that is along radius. Okay. So I'm taking here components, components per weight mg, because tension is now along radius. So we should not resolve it. So coming to mg, along radius and along a tangent. Okay. This is now mg cos theta and this is mg sin theta. So we have taken normal to motion direction and along motion direction. Okay. So now we are knowing that net force towards the center is called centripetal force. So I'm writing here centripetal force equal to mass into centripetal acceleration. Remember, this is not a force. Any force that is only on left side. See here, T minus mg cos theta. That is providing centripetal force. That is equal to m v square by r. R means string length is L, right? It is L. So from this we can write tension equal to mg cos theta plus mv square by L. Suppose question is like v is speed when string is vertical. String is vertical means theta equal to 0. Okay. Then it becomes T equal to mg plus mv square by L. Okay. When string is vertical. That means here tension is maximum when string is vertical. Okay, right. Next, we can see here one more point. Net force along tangent. Net force along a tangent is tangential force equal to mass into tangential acceleration. Tangential force is now mg sine theta. Therefore, mg sine theta, that is tangential force, which is equal to mass into tangential acceleration. So if they ask what is the tangential acceleration, it is equal to g sine theta. That means when string is moving now towards vertical, then tangential acceleration will decrease because sine theta will decrease, right? So writing force equation along radius and force equation along a tangent. So it is just a matter of a free body diagram. Okay, let us see next one. See the question carefully. A toy car of mass 2 kg is following a horizontal circular path of radius 1 meter. Its speed is increasing at a constant rate of 2 meter per second square. Its meaning is every second its speed will increase by 2 meter per second. Okay. Find centripetal force and frictional force at t equal to 2 seconds if speed is 0 at t equal to 0. So see the question carefully. Horizontal circular path, radius is 1 meter. Speed is increasing. We are given tangential acceleration, at value 2 meter per second square, at value. T0, speed is 0. Centripetal force and frictional force at t equal to 2 seconds. Okay. See how to start it. First of all, we are given tangential acceleration is 2 meter per second square, right? At t equal to 0, velocity is 0 condition. At t equal to 2 seconds, we have to find frictional force, also centripetal force, right? Let us see how to start it. Given horizontal circular motion, right? So here mg and normal reaction both are along vertical. mg and normal reaction both are along vertical. So only force acting in the horizontal plane is frictional force. And remember, At is non-zero. So there is now centripetal force that is mandatory along with that tangential force. But we are knowing that the only force in the plane of motion is friction. So from this we conclude that one component of friction provides centripetal force, remaining component provides tangential force. Okay, so this is now frictional force. One component is providing centripetal force, remaining component providing tangential force. So we should be very careful here. In earlier questions, we have seen that no tangential force. No tangential force means friction force providing centripetal force. But now it is having tangential acceleration, right? That's why friction is not towards the center. This is what we have to keep in mind. Now see carefully what we have to calculate. First, centripetal force when t equal to 2 seconds. Centripetal force equal to centripetal force equal to Centripetal force equal to mass into centripetal acceleration, right? Centripetal acceleration is v square by r, right? And r value given, I think r is given 1, right? R equal to 1 meter. So taking r value is 1, it is 1 mv square by r. And mass is given 2 kg. Then see carefully centripetal force, mass 2 kg. Before that, we have to find what is V when t equal to 2 seconds. So since AT is a constant, we can write V equal to U plus AT into T. It is 0. AT value 2, asking at T equal 2 seconds. So V value 4. So mass is 2, V value 4. So 4 square. 4 square 16, it is 32. That means centripetal force is now 32 Newton. Okay. Next he's asking frictional force. Frictional force means it is now net force, right? So net force equal to, in circular motion, net force equal to resultant of centripetal force and tangential force, right? So square root of sum of the squares. Okay. We got now centripetal force. And coming to tangential force, it is mass into tangential acceleration, right? And mass equal to, it is, mass is going 2 kg, it is a 2. Tangential acceleration is now 2. It is equal to 4 Newton, right? That means now we have to find resultant of these two. Okay. So AT value is given, right? That means now substitute values here. We get now net force because we got F tangential and centripetal force. So here the main thing what we have to keep in mind is friction is not providing centripetal force. One component of friction providing centripetal force, right? Because in earlier problems we have taken speed is a constant. That's why no tangential force. Therefore, frictional force is centripetal force. Okay. Let us see next problem. See the question given. A particle of mass m is suspended from a ceiling through an inextensible massless string of length L. The particle follows a horizontal circular path. This is known as conical pendulum. Find its time period of revolution. So given a particle of mass m suspended from a ceiling, length is L. The particle follows horizontal circular path, and this is named as conical pendulum. Time period of revolution. Let us see. Let us draw a diagram for the given condition. With vertical, it makes some angle because when particle follows circular path means given horizontal circle. Okay. So just focus motion of the particle. focusing only motion of the particle. It follows now horizontal circular path, right? Therefore, again, we have to focus first of all free body diagram. So mg vertically downwards, tension along the string length. So only two forces are acting on the particle. So again, we have to focus which force we have to resolve, right? As usual, we have discussed that resolve forces along motion direction and normal to motion direction. So motion direction means direction of velocity. So here you can see normal to plane of circle net force must be zero. In the first we have discussed while discussing dynamics of circular motion, Fz equal to zero means normal to plane of circle. So we can say here mg is now normal to plane of the circle and this must be balanced by one component of tension. Okay, so I can take one component of tension here. It is vertically up. Now that is balancing theta. This is theta. So it is now t cos theta. So first condition Fz equal to 0. So I'm writing here t cos theta minus mg equal to 0 or t cos theta equal to mg. Right? Right. Next, remaining component of tension that provides now centripetal force. Remember, this is now center of the circle, right? Therefore, centripetal force is now, it is a T sine theta, one component of tension provides centripetal force. Or we can say same thing that like that, it is resultant of tension and gravitational force providing centripetal force. I am repeating, we can say that resultant of tension and gravitational force is providing centripetal force because these two are balanced. This is nothing but resultant of these two. Okay, so both are same. So T sine theta equal to yeah, radius equal to L sine theta. It is L sine theta. So M R omega square because we have to calculate now time period of revolution. That's why I have taken m r omega square. Okay. Otherwise, we can take m v square by r. So from this, we can get sine gets cancelled. So t equal to m l omega square. Now substitute this in the above equation in the place of t. It is now m l omega square cos theta is equal to mg, right? Mass gets cancelled. Omega square or omega equal to root of g by L cos theta, right? So once we got omega value, so we got omega value here. Therefore, time period is given by, take it as a t dash time period is, that is equal to 2 pi by omega. So which is equal to 2 pi root of 2 pi root of L cos theta by g. Okay. This is now time period of revolution. So here mainly majority getting a doubt like which force we have to resolve. So first observe plane of the circle. It is horizontal. So vertically mg is there. So definitely tension component has to balance that. That's why we have taken component of tension. Otherwise you can say along the motion direction, normal to motion direction. So here you can see t cos theta is normal to motion direction. T sine theta also normal to motion direction. Mg also normal to motion direction. Here no component is along the motion direction. So that is what we have to keep in mind. That means there is no force along the tangent. That means speed is a constant, or we can say omega is a constant, right? Let us see next one. See the next question. See data given. A particle is having a subtler horizontal motion in contact with the smooth inside surface of a fixed right circular cone with its axis vertical and vertex down. The height of the plane of motion above the vertex is h, and the semi-vertical angle of the cone is theta. Find the time period of revolution. First, understand what's the question given. There is a cone. Okay, no? There is a cone. This particle follows now circular path inside the cone. And given that vertex is down. Okay. And you are given one more. Height of plane of motion is h. And semi-vertical angle is theta. Right. First, let us make a diagram for the given data. Then we can focus how to start it. Let us make a cone. This is given angle is alpha. Let us take the particle is in circular motion at a height h. H is given. Let us take it is now somewhere here. This is a plane of the circle like this, and this height is given as h from the vertex, and this angle will theta right or alpha, anything is okay. Right, now focus carefully. How many forces are acting on the particle? So free body diagram. So first one, mg downwards, mg downwards. Second, normal to the contact, we are having normal reaction like this, normal reaction. Only two forces are acting on the particle. And again, just like the previous question, what we have discussed, conical pendulum, in the place of tension, we have normal reaction, right? And mg as usual. So we can take one component of normal reaction has to balance mg. This is given alpha. Therefore, see what will be the this angle. This angle is alpha. This is 90 minus alpha. See carefully once. With the vertical, this makes angle alpha. So vertical, this makes angle alpha. This is 90 minus, right, 90 minus alpha. Therefore, n cos 90 minus alpha. N sine alpha is equal to mg. So along z direction, there is no net force Fz equal to 0. So n sine alpha minus mg equal to 0. Right? Now remaining component is a providing centripetal force. So one component of normal reaction providing centripetal force. Or same thing we can say that resultant of normal reaction, resultant of normal reaction and gravitational force is a providing centripetal force. So both are same. Now see carefully. This angle is alpha. This is 90. This is 90 minus alpha. Remaining is alpha. So n cos alpha N cos alpha is providing centripetal force which is equal to m r omega square. It is m r omega square. Now take ratio. Tan alpha is equal to mass gets cancelled. It is g by r omega square. Okay. If you want to find out time period in terms of given values like h, then what I can do here? In the place of tan alpha, from diagram, tan alpha equal to opposite radius by a adjacent side is h. So in the place of tan, or if you want to eliminate r, in the place of r, what we can write? H tan alpha, because alpha is given. So I am taking in terms of alpha and h, g by in the place of r, h tan alpha into omega square. Therefore, omega equal to root of g by h tan square alpha, right? So after having omega value, now we can write time period is 2 pi by omega. 2 pi by omega, that is 2 pi under root of, it is h by g into tan alpha, right? This is now time period in terms of given height and angle. Okay. Suppose if question is like, find what is speed. Find what is speed. Then see how to solve. The only change is in second equation, in the place of r omega square, we can take mv square by r. The same thing we can take it as m v square by r. Then see what happens. Tan alpha is equal to m gets cancelled g by r by v square, right? Check it once. I am taking ratio g by v square by r comes here, v square by r, right? In the place of r, I can write r equal tan equal to, in the place of tan, I can write r by h, r by h, r gets cancelled. So we can get a speed in terms of only height, that is root of, wait, what we get here? Yeah, v square equal to gh, v equal to root of gh, right? That means speed depends only on height. It is not angle. Okay. So like this we can solve. Just focus on free body diagram. After that, take components like along tangent, along radius. Next, normal to plane of circle. Right? I hope you got clarity.